Engineer versus Designer is brought to you by the Mojo 3D printer. Now you can have 3D printing right at your desktop at a remarkably low cost. With the magic of Mojo, there's really no limit to your creativity. See it at mojo3dprinting.com.
Adam, if design were a cold pile of sandwich fixins, you'd be the 2 slices of soggy white bread smeared with mayonnaise.
Just the way I like it. Welcome to Engineer vs. Designer,
The podcast.
for product designers,
engineers,
and people who have dreams of riding 6-legged robotic beasts into the sunset. My name is Adam.
and my name is Josh. Each week we bring you the freshest product design juice squeezed straight from the lobes of our esteemed guests. This week we talk with Gui Cavalcanti, robotics engineer,
Founder of Artisans Asylum in Somerville, Massachusetts,
and instructor for the Hexapod project.
along with fellow instructor and controls engineer Dan Cody.
And also along with fellow instructor and electrical engineer James Whong.
And a savvy crew of students.
They've hit their $65,000 goal on Kickstarter.
And then some.
What are they using it for? To complete Stompy, an open source,
18-foot wide,
4,000-pound,
6-legged
hydraulic robot you can ride.
Wow. Guys, welcome to the show. Our first question for you, if you had the choice between riding a unicorn through rolling green hills to the score of Blade Runner, or riding a rocket-propelled emu through downtown Boston to the theme song of the Power Rangers TV series, which would it be?
I've always wanted to ride an emu, and the music choice seems more thematically correct to me there. So I think the emu, yeah.
I was also going to go for the emu, specifically because of the rockets. Yeah, I would like to see that happen.
I would choose a rocket-propelled emu as well, no doubt.
Okay. All right, I didn't ask you, Josh, but no doubt you would. And speaking of epic scenes of mythical animal rides, Josh, strap the reins of knowledge around the unbridled mane of ignorance. What have you got for us this week?
We are delighted to have the first people on EVD leading a team toward building a massive 6-legged hydraulic rideable robot. Now, let's get into the nitty-gritty here. Many may claim, but I think you just initiated the robot revolution.
Yes.
All right, I'm pretty sure. Robots from the early 1950s, toy designs to movies like iRobot, and now DIY and personal manufacturing projects. The world just can't get enough of these things.
Cannot get enough robots, Josh.
No, but do you guys, you're actually making it happen on a massive scale, just huge, and have successfully funded your project on Kickstarter, okay? So tell us, why do people love robots? What's this fascination? Do you think you've started a revolution here?
So, that's a huge and complicated question.
Yeah. Well, I mean, our society has such a strange relationship to robotics. You know, on the one hand, being a roboticist, both of us, I think we often get approached with, people who have ideas of some repetitive, boring task that they'd rather not be doing and that we should make them a robot for, right? But on the other hand, robots are going to take over everything and, kill us all, right? And it's a very strange way to view the situation, and the reality is that neither is true, right? Robotics is actually a pretty nascent field. We're not super good at things yet. The real world is complicated to
interact with.
Yeah, it's a hard environment to exist in and to reason about.
So I don't know. I think a lot of people don't know whether to be scared or excited by robots. Can you each, in sequence, probably Guy first? Can you tell us in one sentence why you personally love robots?
I love robots because I've always wanted to create things that would then run away from me and have a mind of their own. That always seems like a really cool thing.
A lot of people have children for that. Dan, what do you think?
I love the idea of robotics as a reflection on myself, right? If we can make some machine that has some behavior, I feel decently confident that we understand why, how that behavior is actually happening when when we see that in nature or in other instances. And so I think it's a really cool way to put to the test a lot of our ideas about how we work internally.
So it's kind of a proof of comprehension of life. I like that.
I couldn't have said it better myself, really. I could not have.
We can't wait to talk to you more about how the Hexapod project came together and how you guys operate at Artisans Asylum, fabricating hydraulics, robot legs to fund on Kickstarter. But Josh, I think you can stop pretending to feed the three-toed sloth you made from discarded Furby parts strapped to your shoulder. We do have guests. Okay, so Guy and Dan, before we get into the deep and provocative interview segment at the end, we're going to ask you all kinds of difficult and searching questions. We wanted to get a few thoughts of yours on this new idea we have.
Yes, this is the segment where we get your input on a brilliant idea.
It might possibly maybe be brilliant.
It's up for debate.
It's a cool idea we came up with over the macchiatos last week called Litterbot.
Yes.
Josh, what's the pitch?
Okay, Litterbot is a spherical, fully automatic cat litter clump extractor that wakes you up at intervals throughout the day to roll around in the litter box picking up clumps. Now, when not in action, Litterbot emits a laser light show for your cat to be entertained while
that
you're
is the killer app.
work.
That's the killer app as far as the cat's concerned.
Yep.
Yeah. So what do you guys think?
So I think this is cat hell. I can only imagine it malfunctioning after day one and constantly rolling around in the cat's litter box, preventing it from pooping or being anywhere, while constantly barraging it with a laser light show that it can't understand.
See, I think that's actually the intended purpose, to keep the cat from using the litter box. Right? It'll be too distracted chasing the lasers. I think that'll make the lump pickup task a lot easier. You could just prevent them.
Well, I mean, so clearly humans have trouble with the idea of robots, as we discussed a little bit in the first segment. But do you think animals have the same hang-ups? I mean, maybe they aren't as biased as we are about these things.
I think they're as likely to run for the hills as the others.
Maybe a little more.
There's some new tool that can help them in some way.
Based on most cats' reactions to the Roomba, whenever it enters the room, I'm pretty sure that's absolutely true.
Yeah.
So yeah. All right. Well, I think these guys are probably right. This is probably not a good idea, at least from a cat's perspective. It does remind me of a conversation we had about concept designs for instruments of robotic delight.
What?
Or rather, how robot design projects begin. Do you guys start when you're Guy and Dan? When you guys are starting a robot project like this cat litter box Roomba from hell? Do you start with the innards, or kind of start with a structure, a gantry, or do you start from the outside, what you want it to be, and then work your way into the details? How does that work?
So what we did to get started was just back of the envelope calculations. So we said, assuming a robot that can carry two people, how much force would the whole rest of the leg structure have to exert on the ground? Mm-hmm. And so we honestly started with sketches on sheets of paper, sketches on a whiteboard, basic free body diagrams, just to kind of get a sense of how hard the problem really was.
Mm-hmm.
And what sorts of tools we might be able to use to approach it.
Okay, I'm actually going to throw this out there because I know that we have a lot of software peeps listening to this, and a lot of them bug us when we don't bring up software in a conversation, so I'm going to. You guys, clearly, you're talking about back of an envelope calculations, and I think there are a lot of folks out there that want to replace the back of that envelope with a piece of software. Is there a reason why you don't design this in some fancy mechanical CAD system from the conceptual phase? Or, is it just availability?
I do. So the sketches quickly became SolidWorks sketches, which we could update on the fly.
Mm-hmm.
The calculations quickly became Python scripts to run more and more complex simulations.
Oh, great.
Yep. So we have a full IODE-based simulator that helps us simulate the size of the full robot.
Mm-hmm.
And that was pretty critical to figuring out how much flow we needed from our power plant, various sizes.
Do you ever use, finite element analysis and all that kind of stuff to figure out how these things work, or what?
So we use finite element analysis towards the very end of the project.
Okay.
In the SolidWorks environment, but that was only after we had a full structure.
So this has been a big question for me for a long time. I'm not an engineer. I'm the designer of Engineer versus Designer. And I think the idea of running structural analyses on an object, a mechanical object, in advance is pretty cool. But I think that the reality of it is really complicated and frankly scares the hell out of me. Do you think that it would help you if design, if software like SolidWorks had easier to use FEA kinds of tools so you could use them earlier in the process? Or is there a reason why that only happens at the very end?
It would be great to have a software suite that we could easily use to do like free body diagram kind of stuff. And we didn't spend too much time doing that. But like the first pass, how much force is this going to take? That we all had to approximate by hand, and we only refined later with the hard-to-use FEA.
Right.
Yeah. So I would say that the challenge in this kind of design is that you need to be able to chunk it out so you can make some assumptions
right.
for how all of the different systems are going to interact, right? We can definitely make a leg strong enough. The question is, how much is it going to weigh? And then that helps us choose, or that affects the size of the actuators we're going to need, which affects the size of the hydraulic.
It's all interconnected. Yeah.
The Autodesk Force Effect software that's a free body diagram generator, it's actually really, really smooth.
Yeah. So my point is that it's iterative, right? You need to be able to make these simplifying assumptions like, yes, I think that this is possible.
Right.
We'll figure out the details later.
Right.
And then go run with that decision in some other aspect of the design. You can kind of keep coming back together until you converge on an actual solution.
That actually reminds me, way off topic, it reminds me of talking to my grandfather about when he used to work for NASA back when he was using slide rules to put people on the moon. He worked on the space shuttle. And with a slide rule, if you've ever used one, they don't do decimals. You have to know the decimal place in your head in order to do the calculation. And so what's interesting about that is that it means that when you're working with a slide rule, you have to know what you're doing. You have to be paying attention and making assumptions and guesses and knowing approximately the answer that you're after. And a lot of times, what he'll say is a lot of times kids, when he teaches today or whatever, kids will whip out their calculator. They'll get something that's off by a factor of 10 or 100 or 1,000 and not realize because they had no idea in their head of what they were going for. They just kind of used the machine, and the machine gives them the wrong answer. It sounds very similar to what you're doing, where you need to know what you're trying to do, and then and make some assumptions and have it in your brain first before the machine can help you.
I'd say that's basically right, and that was the point of the initial back the envelope. Like, what is the size of number that we're looking for?
Right.
Because we didn't know. Right now, we're using actuators that generate 18,000 pounds of force.
Holy cow!
Right?
Oh, dang!
So, and now we've come to see that as normal, and it's terrifying.
Wow.
Yeah, that would hurt probably a little bit. Yeah. Okay, great. We'll get into the details a lot more a little later on. Stay tuned next week where we will discuss our next great idea.
Discussed it. That's right. We'll be right back. Welcome back, EVD listeners. Today we're talking maker spaces and giant open source robots.
Yes, our guests, Gui Cavalcanti and Dan Cody.
Gui is founder of Artisans Asylum, a hackerspace in Boston.
They're instructors for the six-legged, successfully kickstarted walking robot project, Stompy the Hexapod.
Check it all out at projecthexapod.com.
Okay, guys, you both attended Olin College of Engineering. What inspired you first to get into engineering and robotics?
So when I was in high school, I always thought I'd be a computer scientist, and then one day I realized that I was kind of unsatisfied just turning on and off pixels on a screen, and I really valued having a physical product at the end. And so I'm still a programmer. I wiggle my fingers for a living, but I like that I get to wrestle some metal every so often, and I like that I get to make stuff move. That feels good.
There you go.
As for me, in elementary school and middle school, I wanted to be a paleontologist for the longest time. Yeah, and then I realized that I'd never get to see the thing I studied ever. That got really bad. So I then decided to make my own and jumped into robotics.
That's great. So what led you to start the Artisans Asylum?
So that was about 2 years ago. I felt like I needed a hobby. I was coming home from work and reading and going on the internet and felt like I wasn't doing much of myself. So it started as a 1,000 square foot space where it was just, let's put enough tools in the space to make robots. And it's now a 40,000 square foot space.
And nice.
It's very different.
Wow. How many people does it take to support a space that size?
About 250 to 300 members a month and around 250 students a month.
What about the staff?
Okay, so
we have a full-time staff of 3 and a volunteer staff of around 15.
That is incredible. What a success story. Now, so you guys, now that we know where how you got there, what is Artisans Asylum? What's your mission? What does it want to be? And are you what you want to be?
Yeah, so Artisans Asylum is a community access workshop, right? So you pay for a membership. You get access to heavy manufacturing equipment from woodworking to metalworking to welding, everything in between, electronics, computer-aided design, all that kind of stuff. It's a little village, so it's got 120 renter. I wouldn't call them cubicles, but like renter studios. And it's this huge mix of artists and craftsmen and entrepreneurs and engineers all working on physical products. Wow. And it's awesome. I mean, it's exactly what I've wanted. I've wanted a huge community that, can attract the kinds of people that, this team has attracted and put into a separate project. That was the whole idea, is attracting really awesome people and giving them a place to do work.
So what sort of struggles did you face when you started the Makerspace? Did you think you'd eventually be building a rideable robot when you started it?
I hoped. I did not allow myself to believe. Right. The challenges are huge. They range from, getting shut down by the city because you're not up to code, to finding enough to pay for tools. We now have over $300,000 worth of tools in the space.
Wow.
3/4 of those, though, were brought in by members, and they get discounts off their membership. So there are a lot of really unique solutions we had to figure out.
That's a pretty audacious thing to do. I mean, really impressive. How do you think? Do you think we should make? First of all, should we make design and personal manufacturing more autonomous? Or is it, should it remain more of a hands-on thing like you guys are able to do there in the Hackerspace where you're building stuff? I mean, should people be relying more and more on automated techniques like printing? Is that just another tool, or is it beginning to replace more conventional things like welding and sand casting and that kind of stuff?
I don't know. There's certainly something to be said for the iteration in the design process. I think it's important to kind of get multiple revs of something done. I don't know if it's as important to do it yourself, sitting in something booth or, sitting in the wood shop making.
Well, let me just throw something out there for you. I mean, because this is something that's close to my heart. I know that I've done a lot of design both ways, actually. I've designed products where I'm working primarily digitally and having things printed or fabricated for me. And then I've done other things where I get down in the shop and actually start making it by hand. And they both have their advantages. I think they're both important ways of thinking and working. But just to play devil's advocate, I'll throw out there that building something by hand allows you to, make a lot more mistakes more quickly. You kind of get it out there and you're feeling it, in real time, and you learn from it. It's a conversation. Whereas I feel like with 3D printing, you're more dictating. Right, you're writing what you think in your head and then hitting print, and then that's what happens. Whereas if I'm building something by hand, it's constantly feeding back to me as I go. Do you have that experience at all?
So I would say, there are limits both ways, right? So if you're working on a table saw or if you're working with bandsaws, there's just certain things you can't do, right? It's just impossible to achieve certain levels. At the same time, if you're in SolidWorks and all you have is the fillet button, right? Like, it's only going to look a certain way because you've only trained up on SolidWorks a certain amount and your brain only thinks a certain way.
Right.
And if you're in ZBrush, you're creating big organic shapes, but you're not creating anything dimensionally accurate. So I think you're restricted by tools either way. I personally, you know, for small stuff, I love 3D printers. I push to make them faster. But for big stuff like this robot, you know, nothing beats being in the welding shop.
Yeah.
Trying to figure out how to help.
Sure, or just having the skills to be able to recover from things that go wrong in the field, right? I mean, you don't always have access to a 3D printer, right? You don't always have access to a nice soldering iron you're used to, right? And sometimes you need to hack stuff up. And I think that is definitely a useful skill set to have trained up in the reserve.
All right, now, if Artisan Asylum was given $1 million tomorrow and had to spend it in 24 hours, what would you guys do?
Buy all the tools. So we probably invest we'd invest pretty heavily in a water jet cutter. We'd invest pretty heavily in the pro shop versions of many of our tools. So a lot of our, you know, small saws or whatever break down, and you can replace them with a 1,500-pound bandsaw, for instance, or just stuff that's bulletproof. Right now, we kind of burn through a lot of small stuff.
Oh, right. Well, so you guys are building a 4,000-pound six-legged robot. Last time I checked, 4,000 pounds is more than I can lift. That might have changed recently, but I think that's true. So you're probably working with more than 1 or 2 people, right? You got a team working on this, is that right?
That's right. There's 19 of us working together on this.
Wow. And how was that team assembled?
So we originally offered a class through the Artisans Asylum entitled Robotics Intensive, Rideable Hexapod. And within 4 hours after the announcement, our waiting list was full. So we have the 3 instructors. There's myself, Gui, and then our 3rd instructor is James Whong. He's on vacation today. And 15 students, and we have a TA, Adam Burku, who's actually a 2-time BattleBot champion.
Wow.
So
serious pedigree there.
Team. Some people are experiencing robotics for the first time in the context of this class. Some people are professional roboticists. We have programmers, mechanical engineers, recent college graduates. It's a really diverse group, and I think that's to the benefit.
The Hexapod's name is Stompy. Love it. For the very first, for the people who are hearing about this for the first time, what's your goal for the Hexapod, and how did you approach your Kickstarter campaign?
I said this yesterday, I'll say it again. Our goal for the Hexapod, for everybody involved, is for each team member to be able to take their significant other on a ride into the sunset on a giant 6-legged walking vehicle.
I love that. That's great.
I mean, realistically, though, the idea is to build something huge and awesome that, you know, doesn't have to be funded by the military or the National Science Foundation or whatever in order to be able to exist. It's
no DARPA stickers on there, I guess.
Phenomenal. I think the homegrown story is amazing. The fact that you guys aren't using external funding.
Yeah, Stompy is unique primarily because of the way it's being developed. It's a community project, right? The funding is from the community. The team members are from the community. The knowledge is going back to the community in the form of open source hardware and open source software, and that's something we're really proud of.
I mean, does that mean that if DARPA came along and offered you a bunch of money, you wouldn't take it?
I think for us it means if they want to buy a product, they're welcome to buy a product. But I don't think unless they're interested in developing specifically for them.
Yeah.
Well, I mean, incredibly complex machine, both complex physically as well as complex software, I'm sure. Lots of sensors you're going to need, all kinds of stuff. Hydraulics are going to be a big engineering challenge. What's the most challenging engineering aspect of putting this together from a technical standpoint?
I would say it's dealing with the bargain basement components that we are able to afford. It turns out that, as a rule, actuators are awful to work with, and sensors are awful to work with. And if you want good ones, you got to pay a lot of money. You didn't. So
when we say a lot of money, I mean our valves cost about $100. really, really good valves can cost upwards of $10,000 to $20,000, right?
Ooh,
For reference, there are 18 valves on Stompy.
Okay, so he's potentially expensive.
Okay.
Well, or just, you know, a big time suck to get over the badness of our components.
Right.
Oh man. Okay, I'm gonna take this in a little bit different direction now. I love the robots as much as the next guy, but you know, they still feel so cold and unhuman, despite their helpfulness. Not that they have to be more human-like, but how can we make robots more fun? I mean, you guys are, but making them more helpful and I guess important to some people, more personal.
So that's kind of a complicated question because Americans don't really like robots with personality, or rather, they love them on TV and they hate paying
bit
for them.
creepy.
Yeah, so robots like the Roomba, which are cute and don't have anything resembling a face, but fulfill a very specific niche, people love, right? But like Rosie the robot with, you know, as close to a human face as possible would creep everybody out and start accusations of zombies and robot apocalypses and all that kind of stuff. So I think focusing on, you know, individual things that people really want done and doing it in a perhaps cute or interesting manner is what's going to cause people to actually start to adopt robots in their everyday life.
Yeah, I would say it's a perception problem. Right? The Roomba, people ascribe personalities to the Roomba's behavior, but it's so far from a human robot that it's not a human personality, and they don't expect the Roomba to obey human customs and to interact in the way that we do with each other. I think the closer you get to a humanoid shape, the more people expect you to behave in a humanoid way.
Right. And there's no telling what an animal is going to expect when they see a 4,000-pound hexapod robot walking into the sunset. So, I mean, you guys have pretty impressive robotics resumes, each of you, lots of robot building, mechanical systems, control systems. How has teaching other people to make stuff changed your own approach to making?
For me, it's almost like it's half teaching and half just project management. And that's one thing we set up from the beginning of the project, is that we knew we were going to have our hands in it a little bit to get it to work. And it's teaching me a lot about what teams are capable of doing together and what they're really not. So what they're capable of doing together, fabricating, absolutely. Like everybody can take a bit, they can go off, they can go weld, we can make them better welding, everybody can be self-sufficient. Making big design decisions by voting or talking about things, like that's great. You know, individual detail design is not really a team thing. It's a very specific, you know, one or two people does a thing, other people check on it, right? And trying to make it a committee process is pretty doomed from the get-go.
Yeah. I'd say, this is cliche, but the questions that you get asked are what I learned from the most. You know, and sometimes your intuition was correct, and you were able to come up with you know, a solidly founded explanation for why the, you know, X design decision is the correct one. But a lot of times I'm not able to, and I'm forced to evolve the way I think, and the way I approach problems through those questions. So that's been great for me.
Now, much like how drones were once tens of thousands of dollars to purchase, only a few years ago, a maker, somebody savvy with electronics, can just purchase a kit for under $1,000 and build and program their own drone design with even better capabilities. How will this kind of personal manufacturing model fit into what we'll be able to build in our own homes? And what do you guys think in 5 to 10 years?
I don't know that people will ever really want to be building in their homes, but I do think what might happen is you might start seeing retail shops. But I think people will be interested in like going down to the storefront that has a 3D printer and printing up, you know, whatever it is they want, right? Like drawing from a library online.
I'm excited for the first time I get to print a replacement part for some device I own that a manufacturer just you know, sent over the file for.
Yeah, absolutely.
So will the success of the Hexapod project combined with your love for hacking and robotics, steer you towards building more writable robots? I mean, do you have a unicorn robot, perhaps, in the work? Maybe an emu? Where are you going next?
So I've always dreamed of building a zoo's worth of writable robots. Like, I go to a zoo and I see all these sad animals in cages. They can't do anything, and obviously I can't interact with them, or else I would die. So I think it'd be awesome if we had a theme park that had no cages in it, right? Just had these robots which are either drawn from biological inspiration or just totally made up, right? Which people can actually interact with and ride and talk to. And it's a whole new type of experience, right? It's a whole new type of art.
I'm buying a ticket. Okay, one last question for you. How can we create makerspaces that encourage kids to innovate and build more? What do we do?
So Make Magazine is doing this. I don't know if you know, but Make Magazine got a DARPA grant to put 1,000 makerspaces in high schools. So they're rocking out and getting some really cool stuff done. But I think, encouraging high schoolers to join robotics teams, that was what I did in high school. Spent 4 years on our first robotics team. James was in bot ball for, I think, 3 or 4 years. But I think that's a good way to go, is encouraging the projects that they work on, and not so much the ethos of making, because I don't think they're going to get it until they've made stuff.
So are we gonna see you guys at Maker Faire in New York?
Will we see a Stompy demo?
You'll see Stompy there. You'll probably see a couple of us. I know I'll be floating around, but we have one leg right now, just to be clear.
Well, Stompy is doing a little, he's tapping his toe, one toe at a time, and eventually maybe there'll be 2 or 3 and 6. Well, we're out of time, but thanks so much, Gui and Dan, for joining us. Having you on the show has been even more fun than that time Josh thought that his brain felt rusty, so he sprayed WD-40 in his ear. Thank you so much for your time today.
Thank you, guys. All right, thanks so much.
Yeah, thanks again. Well, that's it, folks. If you'd like to send your own blueprints for building a giant rideable robot to EVDHQ, please address that to Josh. Yes.
And if you would like to send a case of WD-40, please address that to Josh.
We'll need it for our Litterbot prototypes, indeed.
Best comment this week wins an Engineer vs. Designer t-shirt, so make sure to let us know what you think at EngineerVsDesigner.com.
If you'd like to see us personally testing our Litterbots by rolling around in cat litter, be sure to like us, +1 us, tweet us, or whatever else as social media has been correlated with severe halitosis.
The show was edited by Simon Martin. Our theme music is by the Red Hook Ramblers this week.
We'll see you next week, and remember, if blood spurts out the air hole, pull the Q-tip away from your pulsating brain vein. Yes, do that.
Hadn't thought of that one.
Where's my robot sloth? Nobody knows.
Hiya!
Look out! Engineer vs. Designer is brought to you by Mojo 3D Printer, a world-class professional 3D printer for only $185 a month. To find out how you can give your big idea a little mojo, visit mojo3dprinting.com.
A production of EVD Media.